Alright guys, this is Miss Humeniuk, and I'm going to be talking with you about parallel and perpendicular lines. I'm going to be introducing that to you today. And so what we're going to do is first we're just going to talk a little bit about it. So with parallel lines, a symbol that represents parallel lines when you write it is kind of two little lines like that, little slashes, all right? And the reason why is because parallel lines, if we draw a picture of them, they are two lines that never intersect. And so, kind of answering my question here, we see that parallel lines, they never intersect, all right? Unless they are the same line. All right, so they never intersect unless they are the exact same line. And the slope for two parallel lines is they have the exact same slope. Okay, so if the m of our given line, let's say, is 2/3, then I'm going to go over here. I'm going to do a red because go Highlanders. The m of our, let's say, parallel line would also be equal to 2/3. All right, they have the exact same slope. All right, so I'm going to change that to say given line, and that's our parallel line. All right, now when it comes to perpendicular lines, the symbol for that is this little kind of upside down T. And that is because perpendicular lines, and you can illustrate this several ways, they do intersect, but they intersect in a special way. They intersect where they form a right angle, which is also 90 degrees. Now, we could draw them like this. We could draw them like perfectly up and down, all right? As long as the angle between them is 90 degrees, then they are considered perpendicular lines. So yes, they intersect. Yes, and they just intersect at one point, all right? And this is where they form a right angle, okay? And the slope for parallel lines, this is kind of like, this is a big boy math word right here. The slope is a negative reciprocal, which is kind of a big word. Reciprocal. There we go. So say that 3 times fast. Reciprocal, 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 right? And so that means if the slope of my given line, let's say, again, is just going to be equal to 2/3, then the slope of my new line, of my perpendicular line, would be negative 3/2. So basically, guys, a negative reciprocal, basically what it means is that you flip the fraction and then you change the sign. You flip the fraction and you change the sign. So if this slope was 2/3 of the given line, our perpendicular line would be negative 3/2. All right, we just flipped that fraction and then changed the sign. So now let's put it into practice. All right, y'all? So let's look over here at this example. What is the slope-intercept equation of a line parallel? So we know parallel means same slope to y equals 2/3 x plus 1 and goes through the point negative 3/6. And then it's going to ask us to graph the both lines. So the first thing I like to do is I like to write my given line. My given line is y equals 2/3 x plus 1. And the reason why I like to do that is because then I can know that my slope is 2/3 of that given line, okay? And then what will come in handy when we graph it later is that b, that y-intercept, is equal to 1, right? Now for my parallel line in this case, we know that our slope, our m, is going to be equal to 2/3 because it's the same slope, right? We remember, same slope. So it's the same slope. And the point that it goes through is this -3, -6. Okay? So if we have a slope and we have a point, we can write an equation. Now, it wants the final answer to be an slope-intercept equation, but we're going to start with our point-slope equation. So what I'm going to do is I'm going to say y plus 6, because I added -6, equals 2/3 times x plus 3. Now that we have it in our point-slope form, we can solve for y to get it into y-intercept form. So the first thing we do is we distribute that 2/3. So we go times 2/3, and we get y equals y plus 6, that doesn't change, equals 2/3 x, 2/3 times x, then 2/3 times 3 would give me 6/3, which would reduce down to just 2. So we get y plus 6 equals 2/3 x plus 2. And final thing that we got to do here is we got to get rid of our 6, so we're going to subtract 6 from both sides. So we are left with y, cancel that, equals 2/3 x minus 4. So this is our new equation. And the new equation, remember, we already know the slope is going to be 2/3. And we know that the y-intercept is -4. So now that we have all this information, we can graph both lines. So how we're going to do this is we are going to take, let's see here, let's graph our first line, the given line. So I'm going to do this in 2 different colors. So we know my y-intercept is 1, because we got that from our equation, and then the slope is 2/3. So that means we're going to rise 2, and then run to the right 3. Rise 2, run to the right 3. Rise 2, run to the right 3. Okay? And then you take your straight edge, take my ruler, and I am going to just draw my little line here. Oops. All the way through the x-axis. Now remember, so now our new point is what? Our b is -4. So let's see here. So it's going to be right down there at -4. And our slope is 2/3. So we go up 2, over 3. Up 2, over 3. Up 2, over 3. Okay? And I'm going to draw my line through here. Now, what I want you guys to remember is we were given a point, right, of -3, -6. And look at that. -3, -6 goes perfectly through, our line goes perfectly through that point. So this would be the graph of those 2 parallel lines, okay? So now we're going to jump over and we are going to do a perpendicular line, all right? Now the perpendicular line that we're going to do is we actually start with the same line, all right? We want to do perpendicular. So this means that our slope is going to be that negative reciprocal, right? So the slope is not the same. Okay, so our original line, I'm still going to write it just like I did before. The given line is y equals 2/3 x plus 1, right? And our slope is 2/3, and our b is 1. That's great. We already know what that graph's going to look like because we've done it on the first problem. Now, for our perpendicular line, our slope is going to be something different. Our slope is going to be, we're going to have to flip the fraction and change the sign. So just like we did up here in our example, if we flip the fraction and change the sign, then it would be 3, but it's -3 over 2, okay? And then the point that they give us, this is a different point. Our point is negative 2, 4. So if we have a slope and we have a point, then we can write an equation. So let's go ahead and write this equation. So we're going to say y minus 4 equals negative 3 over 2 times x plus 2. Now remember when we're doing point-slope equation, when we put these guys in, that's the one where it flips the sign, right? So because it was positive 4, it became y minus 4, and then our slope stayed the same, the negative 3/2, and then it was x plus 2 because it was a negative 2. All right, so now we're going to go ahead and distribute just like we did on the last one. So we get y minus 4 equals negative 3/2. Oh, whoops. 3/2 x. My bad. I'm trying to get rid of that parentheses. Then negative 3/2 times positive 2 would give me negative 3. Okay? It's because negative 3 times 2 would be 6. Negative 6. Negative 6 divided by 2 would give me negative 3. Now, in order to get this y completely alone, I'm going to say plus 4 plus 4. And my final equation would be y equals negative 3/2 x plus 1. All right? So in this case, we see that our slope is negative 3/2 and our b is 1. So now if we graph this, let's see what happens. So let's graph the two equations. The first one is going to look just like the green one on the left. We start at 1 because our b is 1, and then our slope is 2/3. So we go 1, and then we go rise 2, run 3, rise 2, run 3, rise 2, run 3. So this guy should look just like the one next to it. Okay. And then our perpendicular line, let's see here. Oh, the y-intercept is also right here at 1. But this time our slope is negative 3/2. So now we go down 3 to the right 2. Down 3 to the right 2. Down 3 to the right 2. And what we see, remember our point was that negative 2, 4. So let's see. Oh, look at that. It's going to be perfectly in line. Making sure that our equations are working. Okay. So there we go. So these two lines form, oops, sorry, I didn't really show y'all. These two lines form a perfect right angle. Sorry about y'all. So you can see when they intersect, they form a perfect right angle. So those are two examples of how you find a parallel line and how you find the equations for a perpendicular line and then how you graph them. Okay? Now we're going to flip over. This was page 7 of your packet, the final page 7 of your packet. And now we're going to flip over to the last page, page 8. Okay? And what I'm going to do is you have these two examples on the top, and these are very, very similar to the ones we just did. So I'm going to skip these for now, and I'm actually going to jump down to the bottom of the page because these are different. When you write and graph an equation of a line that is where the slope is either 0 or undefined, okay? So we want to write and graph this equation of the line that goes through this point, negative 2, 4, and is parallel. So when it's parallel, remember, same slope to the x-axis. So if it's parallel to the x-axis, I'm going to go ahead and draw a line on my x-axis. And if I'm going to draw a line on my x-axis, this actually has an equation, okay? The equation for this, remember, it's a horizontal line. It's straight horizontal. So the equation for this line, let's see here. So we're going to think about HOI. So it is a horizontal line. It has a 0 slope, and the equation is going to be y equals. So the equation for this given line is y is equal to 0 because it's wherever it crosses through the y-axis, and it crosses through right there at 0, 0. So our given line is y equals 0, okay? And the slope of this, I guess I should have said m, is equal to 0. Remember with HOI, H-O-Y, okay? So that means that the slope of our parallel line, the parallel line slope will also, the m will also be equal to 0 because remember they have the exact same slope. All right, but it goes through the point -2, 4. Now guys, here's the thing. We don't actually have to do a bunch of math to get the answer to this, because check it out. If our point is -2, 4, and our line is horizontal, then our y is going to be equal to whatever the y value is of our point. So in this case, our y is going to be equal to the y value. In this case, the y value was equal to 4. And you can see that would be true as we graph these lines. So the slope, so 0 is parallel to a slope of 0, okay? The slope of 0 is parallel to the slope of 0. And so that means if this was y equals, then our new perpendicular line would also be y equals. And it's going to be y equals to whatever the y value is, because that's where it crosses through at your y-intercept, which is right there, that y equals 4. Okay? So that is how you write the equation of a line that is parallel to a horizontal line, okay? Now we're going to do the same thing, but over on this side, we're going to write in the graph of the equation that goes through this same exact point, but now it's going to be perpendicular to the x-axis. So now, since it's perpendicular, we know the slope will be a negative reciprocal, okay? But this gets a little messy with our horizontal and vertical lines. So let's think about this. Remember what we said, if it's parallel, so the x-axis, the equation for the line on the x-axis is y equals 0. So this line is horizontal. Our new line, our perpendicular line, is going to have a slope that is undefined because it is a vertical line. Okay, it's going to be the exact opposite, because I want you to think about this. If our original slope is, our original given slope is equal to 0. If I flipped that fraction, okay, now technically it can be 0 over anything, 0 over 5, 0 over 6, 0 over anything. But if I flip that and put any number on top, so let's say maybe it was, 0 over 5. If I flip that for my perpendicular line and made it 5 over 0, that right there is a big no-no. That's when we get our undefined slope. So guys, one thing that's just really important to know is that undefined and 0 slopes are perpendicular to one another, okay? So we will write that really big down here, all right? So undefined and 0 slopes are perpendicular to each other. That's a big deal, okay? Undefined and 0 slopes are perpendicular to one another. So if this is the case, my slope is undefined, which means that it's vertical, because we're thinking vux, V-U-X, because it's undefined. And it goes through this point, -2, 4. So I'm going to go ahead and graph it. It's the same point from the last problem. Now it's going to be a vertical line. So I'm not going to take my ruler, I'm just going to freehand it. And this would be our x-intercept. Our x-intercept is right there at -2. So that means my new line would be x is equal to -2. All right, so that is how you find the slope, and that's how you graph and write the equation for a line that is perpendicular to the x-axis. This is how you did it when it was parallel. All right? If you want to stick around and see these last two examples, you're more than welcome to. I'm going to go back up to the page. Otherwise, you can also get started on your homework. All right? So now, what is the slope-intercept equation of the line parallel? Okay, so when we see parallel, we think, all right, same slope, to y equals negative 3x plus 4, and goes through this point. So I'm going to write my given line. That's y equals negative 3x plus 4. So my slope is negative 3, and my y-intercept is positive 4. So my parallel line, because we're dealing with parallel lines, my slope is still equal to negative 3 because they have the same slope, right? And my point that they give me is negative 2, negative 1. So now that I have a slope and I have a point, I can write my equation. So I have y plus 1 equals negative 3 times x plus 2. Remember, we flip those signs. And now I'm going to go ahead and actually distribute this and solve for my y to get it in slope-intercept form. So I get y plus 1 equals negative 3x minus 6. Okay, I'm going to go here. I'm going to subtract 1 from both sides. And I am left with y is equal to negative 3x minus 7. So now we see that my slope is still negative 3, but my b is negative 7. So if I graph these lovely little lines here, we see my first line, my b is positive 4, and my graph goes, my slope is negative 3. Now remember, when you have a slope of negative 3, it's kind of the same thing as negative 3 over 1. So yeah, it's because any whole number is just is over 1. All right, that becomes important, especially when we do our perpendicular lines. So I'm going to go down 3 over 1, down 3 over 1, down 3 over 1. Perfect. And when we do this, we can get our little straight edge here. And I'm going to graph my line. So that's my given line. Now my parallel line should hopefully look pretty similar. So we have our parallel line is at negative 7. We'll start there. Now I'm going to go down 3 and over 1, but that only gives me 2 points. So I would like to actually go ahead and get a couple more points. So now I'm going to reverse my direction, and now I'm going to go up 3 and left 1, because that's positive and negative, which is still a negative slope. So now I go up 3 over 1, up 3 and over 1. So I just like to have a few more points when I'm graphing. And I'm going to go ahead and, draw my line here. That looks okay. And those two lines are parallel. All right, so that's how you would graph the two lines that are parallel to one another. Now we're going to do this, use the same given line, but we are going to work with perpendicular. And remember, when it's perpendicular, we're going to have that negative reciprocal slope, okay? So we're going to have that negative reciprocal slope. So my given line is just like the one next door. It's y equals negative 3x plus 4, which means my slope is negative 3, and my b is 4, just like it was on the other equation. Now, for my perpendicular line, I'm going to go ahead and use my little symbol here. My slope now, we have to flip our fraction and change the sign. And remember what I said about this slope. We can write it as negative 3 over 1. So if we're going to flip the fraction, that becomes 1 over 3. And then we change the sign, so instead of a negative, now it's going to be a positive. And then the point that it gives us is the 6, negative 4. All right, So now that we have a slope and we have a point, we can write our equation. So I'm going to go here, I'm going to say, okay, y plus 4, because you changed the sign, equals 1/3 times x minus 6. Now in order to solve this into slope-intercept form, because that's what it wants, we have to make it be y equals. So we're going to distribute our 1/3, clean up this right side. So we say y plus 4 equals 1/3 x, and 1/3 times negative 6 is going to give us minus 2. And now in order to get the y completely alone, we need to go ahead and subtract 4 from both sides. And what we're left with is y is equal to 1/3 x minus 6. So this is our new equation. In our new equation, our slope is 1/3, and our b, our y-intercept, is negative 6. So what we'll do is we'll graph our original equation, and we'll look just like the one on the left there. So our y-intercept was positive 4. We go down 3 over 1, down 3 over 1, down 3 over 1. So we see that. And then I'm going to go ahead and graph. Oh, wait. I think I messed up a little. Ignore those points. Sorry. I was like, these don't line up. That doesn't look like it next door. I accidentally went down 4, but now I fixed it. I know, I make mistakes too. Alright, so then, now we're going to graph our new line, so I'm not going to get this one wrong. So let's see here. Our b, our y-intercept, is at negative 6. I'm going to go 1, 2, 3, 4, 5, 6. And then our slope is 1/3. So I'm going to say up 1, to the right 3. Up 1, to the right 3. Up 1, to the right 3. And I got 4 points now. It's kind of nice that they cross right on a point with one another. It doesn't always happen. It's just nice when it does. And then we're going to go a nice little pretty point. Alright, so now we have graphed our new line, which is y equals 1/3 x minus 6. And we see that this makes a very nice looking right angle with our original line. So these two lines are perpendicular, and these two lines are parallel. Alright, so now you get to do this on some homework, and we would like you to, you're going to be given a point, and you're going to be given an equation, and then you're going to need to graph a parallel line and a perpendicular line, and give us the formulas for those. Alright, thank you so much, and I hope you have a wonderful day.